we're continuing the topic of integration that we started yesterday. Let's quickly recap the two cases we discussed yesterday. One of which was y equals e power fx. First, I'm going to consider fx to be a linear function. So the example could be y equals e power 3x plus 1. All right. So if you're integrating this, then the rule of integration is that if you're integrating y, it becomes e fx upon f prime x plus c. Now this is a shortcut of an actual longer rule that we don't need to apply if fx is linear. So the integration of power 3x plus 1 is going to be e power 3x plus 1 upon the derivative of 3x plus 1, which is 3, plus c. However, if fx is not linear, यहाँ पे तो fx was linear. If fx is not linear, then the case isn't as simple. So in that case, if you have to integrate e power fx, it's a compulsion that you must also have a derivative of that being multiplied with e power fx. Only then you can integrate it. And it integrates as e power fx plus c. This time there is no derivative in the denominator. Example of that would be integrate e power, let's say, x square plus x. Now the derivative of x square plus x is 2x plus 1. So you must have that in the bracket as well. 2x plus 1. And then there would be a dx with that. So now the integration of this would be efx plus c. So it's going to be e x square plus x plus c. If this is not there, then you cannot integrate e power x square plus x. Then the second case was if we're integrating 1 upon x dx, the result of integration is ln x plus c. So if fx is linear, then the rule is 1 over fx dx is equals to ln fx upon f prime x plus c. That is, if you have integration of 1 upon 3x plus 1 dx, that's going to be natural log of 3x plus 1 upon 3 plus c. However, if fx is not linear,
मैं 1 over x में नहीं डेरिवेटिव अपने इंटीग्रल के अंदर डाला हुआ.
सॉरी,
मैम ये जो 1 over x का इंटीग्रल है इसमें इसका डेरिवेटिव अंदर नहीं डालना चाहिए जैसे एक्सपोनेंट के इंटीग्रल के लिए किया था.
वो 1 होता है ना, तो उसकी जरूरत ही नहीं है. 1 will always be here. Derivative of x is 1.
ठीक है मैम.
ठीक है. अच्छा, so
मैम
if
इसे x पावर -1 नहीं है?
नहीं, fx का चाहिए होता है ना डेरिवेटिव, fx ये होता है जो डिनोमिनेटर में।
ठीक है मैम, समझ आ गई।
अब जब fx इज नॉट लीनियर तो वो आपसे डायरेक्टली ये नहीं पूछ सकते, they won't be asking you this. They'll definitely be giving you f prime x in the numerator. So अगर f prime x इसके साथ multiply हो रहा है, only then you can integrate this to ln fx. So if you have integration of 1 upon, let's say, x square plus 2x. So definitely numerator में they will give you something in those lines. For example, given होगा x plus 1 numerator and dx here. Now, what's the derivative of the denominator? X square plus 2x का क्या होता है derivative?
2x + 2।
हाँ, but 2x plus 2 तो हमारे पास नहीं है, but एक constant का ही difference है. So what you'll do now, you'll multiply this with 2 inside and outside you write a half. And now you can apply this formula on this. Numerator has fx and the denominator has fx and the numerator does have f prime of x. So we can apply this formula and there's a half outside and we get ln fx as a result of integration. Ln x square plus 2x plus ये हमने कल किया था. Now we're going to discuss the third case of integration, which is integration of trigonometric functions. All right. So before we discuss integration of trigonometric function, let's revise derivation of trigonometric functions. So from last chapter, we know that the derivative of sine x is cos x. Derivative of cos x is sine x minus sine x. And derivative of tan x is secant square x. और सिमिलरली अगर x की जगह fx आ जाता था तो फिर हम f prime x साथ मल्टीप्लाई कर देते थे. So if it's sine fx, then it's cos fx times f prime x. Same rule for cos and tan's derivation. Okay, this is what we did in last chapter. Now we're going to go in reverse. So the integration of sine x is going to be, you integrate this. So you get minus cos x as your answer. Then the integration of cos x gives us sine x plus c from here to here. And then the integration of secant square x gives us tan x. All right, so There's integration of sine x, there's integration of cos x, and then there's integration of secant square x. What about integration of tan x? इंटीग्रेशन ऑफ tan x डायरेक्टली नहीं होता. अगर आप उसका फॉर्मूला रट लो तो बहुत अच्छी बात है, बट यूजुअली यू डू हैव टू शो ऑल योर वर्किंग. सो देन हाउ डू यू इंटीग्रेट tan x? हम tan x को लिख लेते हैं एज sin x अपॉन cos x. Right? Now we're going to use this rule of integration, that if you're integrating a function in the denominator and you have its derivative in the numerator, then who remembers what this is equals to?
मैम इसकी इंटीग्रेशन एफ एक्स ही हो जाएगी प्लस सी.
नहीं, ln fx plus c. ln fx plus c. It's ln fx plus c. So let's see. In the denominator, we have cos x. What's the derivative of cos x?
माइनस साइन एक्स.
हाँ, डेरिवेटिव ऑफ cos x होता है माइनस साइन x. सो अब हमें माइनस साइन x न्यूमरेटर में बनाना पड़ेगा. सो व्हाट विल डू, विल प्लेस अ माइनस साइन आउटसाइड and we'll place a minus sign inside. Now the numerator has the derivative of the denominator. So then what should be the answer of this? ये रूल यूज होगा ना. डिनोमिनेटर में fx है, न्यूमरेटर में इसका डेरिवेटिव है, तो इंटीग्रेशन क्या हो जाती है? ln fx, where fx is the denominator term. So it will be minus ln cos x. So integration of tan x is minus ln cos x plus b. While we're at it, let's also discuss the integration of cot x. वो भी इसी तरह derive होती है. Okay. So that would be integration of cot is cos upon sine. So now is this rule applicable, that we have a function in the denominator and its derivative in the numerator? Is that true in this case? Denominator में sin x है, numerator में cos x है, which is its derivative. तो integration क्या हो जाती है? ln fx plus c. तो मुझे प्लीज कोई बताएगा इसकी इंटीग्रेशन क्या होगी cos अपॉन साइन की?
ln sin x plus c.
Yes, ln sin x plus c. Good. Yeah. So integration of cot x can't be done directly. There's no fixed formulas. You have to derive the answer, which comes out to be ln sin x plus. Okay. अब हम करते हैं इंटीग्रेशन ऑफ साइन एफ एक्स, कॉस एफ एक्स एंड सीकेंट स्क्वायर एफ एक्स. और पहले हम लेते हैं कि एफ एक्स को लीनियर लेते हैं. So when it's linear, we can use the shortcut and we don't have to go into the depths of the topic. Okay. So when we're integrating sine fx or when we're derivating cos fx and when we're derivating tan f, sorry, secant square fx, derivating नहीं, integrating, sorry, secant square fx the result is here f, all the fx is linear, fx is linear in every case. So then the integration of sine fx would be cos fx, and the denominator will have f prime x plus c. Then the integration of cos fx is sine fx. The denominator is f prime x plus c. And then the integration of secant square f.
माइनस कॉस नहीं होना चाहिए तो साइन एफ एक्स की इंटीग्रेशन
पहला
में
वाला minus है. Yes, it's minus. Okay. And then integration of secant square fx would be tan fx upon f prime x plus c. जब लीनियर है तो बस ये यूज करो, दूसरे एक्चुअल फॉर्मूला में जाने की जरूरत. ये कुछ एग्जांपल्स करते हैं. So question है, integrate sine 2x. So linear case है, integration of sine 2x क्या हो जाएगी, minus cos 2x upon the derivative of 2x, which is 2 plus c. Yeah. Integration of cos pi minus 3x pi upon 2 minus 3x dx. So the function fx is still linear because the maximum power of x is 1. So it is a linear function. We apply the same rule. Integration of cos fx is sine fx. So sine upon the derivative of fx, which is minus 3 plus c. Next is integration of secant square 5x minus 5. That will be tan fx upon f prime x, which is 5, plus c. Next is integration of denominator has sine 2x. Numerator has cos 2x dx. So, what should be the integration of this? Cos 2x in the numerator, sine 2x in the denominator. वो वाला case है कि you have an fx in the denominator, then you must have its derivative in the numerator. And if you do have that, then the integration is equals to ln fx. So do we have the derivative of sine 2x in the numerator? क्या होता है derivative of sine 2x? वो होता है cos 2x times 2. So 2 missing है इधर. तो हम 2 multiply भी कर देंगे और बाहर divide भी कर. We write it 2 here and a half here. So now the condition is fulfilled that you have the derivative of the denominator in the numerator. So now you change it into half ln sine 2x plus. Okay. अब हम एक काफी इंपॉर्टेंट केस डिस्कस करने लगे हैं. ऑलमोस्ट हर पेपर में आता है. Still talking about trigonometry part. Now we must learn how to integrate cos square dx, cos square x and sine square x. So how to integrate cos square x dx and how to integrate sine square x dx. अब एक कॉमन गलती बच्चे करते हैं वो ये होता है कि वो ओ लेवल्स का रूल अगर याद हो x पावर n की इंटीग्रेशन, ओ लेवल्स का नहीं as का, इसकी इंटीग्रेशन क्या होती है x n प्लस 1 अपॉन n प्लस 1, ये यूज कर लेते हैं और कहते हैं ये हो गया cos क्यूब x अपॉन 3 और ये हो गया sin क्यूब x अपॉन 3. ये बिल्कुल गलत होता है. The reason is this formula only works for linear x or linear fx. If it's not linear, तो रूल चेंज होता है. मैंने अभी ये वाला केस कराया नहीं, बट वही रूल ये होता है कि fx पे अगर पावर n है और ये fx लीनियर नहीं है तो इसके साथ f प्राइम x भी होना चाहिए. If it's there, only then you can do this fx n plus 1 over n plus 1. तो यहाँ तो cos x का डेरिवेटिव साथ नहीं मल्टीप्लाई हो रहा और दूसरे केस में sin x का डेरिवेटिव साथ नहीं मल्टीप्लाई हो रहा. So you can't use this power rule. That would be absolutely wrong if you try to use power rule. अब इसमें करना क्या होता है सिंपली कि आप डबल एंगल आइडेंटिटी यूज करते हो cos 2x की. Let me write that here. Cos 2x is equals to either sin cos square x minus sin square x. इसकी 3 आइडेंटिटीज होती हैं, फॉर्मूला शीट में होती हैं. और either 2 cos square x minus 1 और 1 minus 2 sin square x. ये सब इक्वल होते हैं cos 2x के. अब हम क्या करेंगे कि हम यहाँ से ना cos square x को सब्जेक्ट बना देते हैं और cos square x की जगह हम लिख लेंगे if we make cos square x the subject, we get cos 2x plus 1 upon 2. I'm going to replace this with cos 2x plus 1 upon 2 dx. The denominator is a constant. You can send it outside of the integration sign. We get half integration of cos 2x plus 1 dx. Now we already know how to integrate cos 2x. It's going to be sin 2x upon 2. Linear function है, so जब cos fx को हम इंटीग्रेट कर रहे हो और fx लीनियर हो तो हम वही शॉर्टकट यूज करते हैं कि बन जाता है sin fx upon f prime x. So that's what we're doing. Half outside. Going to use bigger brackets. And we get sin 2x upon 2. And then the integration of 1 is x. So x plus c. This is what we get. So we may also write sine 2x upon 4 plus x by 2 plus c. Yeah. Similarly, we integrate sine square x and I want to use the double angle identity of cos again. अब हम इसको सब्जेक्ट बना लेते हैं sin square x. So when we do that, we get 2 sin square x को लेफ्ट पे ले जाते हैं 1 minus cos 2x इधर आ जाएगा और 2 डिवाइड हो जाएगा. So this is what sin square x is equals to. So replace sin square x with 1 minus cos 2x upon 2. Okay. So again, I'm bringing the denominator, the 2 in the denominator outside to simplify things. Integration of 1 is x. Minus integration of cos 2x is sin 2x upon 2. Plus c. So we get x upon 2 minus sin 2x upon 4 plus c. That's the integration of sin square x. Okay. And lastly, we're going to discuss the integration of sine, cos, and secant square when fx is not linear. So, in fx is not linear anymore. So, अब क्या होगा आपको कहेंगे इंटीग्रेट करें sin fx, but definitely उसके साथ f prime x या exactly होगा या constants के बगैर होगा कि आपको constant multiply और divide करने पड़ेंगे. So, if this is not there, then you can't integrate this if the derivative is not there. So the integration of cos fx is minus sin fx. Sorry, of sin fx is minus cos fx plus c. Similarly, if they give you cos fx where fx is not linear, they would definitely give you f prime x multiplied with it. So this would be equals to sin fx plus. Lastly, if they ask you to find secant square fx, they would definitely give you a form of f prime x. And then this would be equals to tan fx plus. एक एग्जांपल कर लेते हैं इसकी. So integrate sin x square plus x. अब डायरेक्टली ये नहीं पूछ सकते. It does not make any sense. You cannot integrate this directly unless there is a f prime x with it, which is 2x plus 1. वो multiply हो रहा होगा उसके साथ और फिर आपको कहेंगे कि इसको integrate करो. So then the result would just be minus cos fx plus c. That's it. नेक्स्ट केस कल कराऊंगी वरना बहुत ज्यादा खिचड़ी बनेगी. प्लीज फर्स्ट, सेकेंड और थर्ड केस दोबारा से अच्छे से रिवाइज करके. सी यू गाइस टुमारो इंशाल्लाह. अल्लाह हाफिज.